we get started immediately. We have just 1 hour. Now, we always start with a word of prayer to put this lesson into God's hands so that God guides us through the lesson. Okay, may I have a volunteer to give us a word of prayer? Hey, Daphne.
Yes, sir. Thanks, sir, for the opening.
Welcome, Daphne.
Let's humble ourselves for the word of God. Dear loving Father, we thank you for this day. We thank you for each and everything you've done in our lives. Father, as we're going to study, come and be in the midst of us. Come and take control in each and everything, and also come and give us wisdom, Jehovah Jireh, and come and fill us with your Holy Spirit so that we can understand what the teacher is going to teach us, and also come and control us in and everything. In Jesus' name we pray. Amen.
Amen. Thank you, Daphne, for the prayer and the prayer that God guides us through. All right. So those who are new, we are in mathematics, and here we are looking at vectors. Now, just a quick review of what we did last time, and let's have this. Just a quick review of what we did last time. In our previous lesson, we started by introducing ourselves to vectors, and we said that when we talk about vectors, by definition, we look at quantities that have both direction and also the magnitude. And in our previous class, we saw how the direction comes about. And then we did some bit of calculations. Then we also looked at the representation of a vector. And we said a vector is represented in two forms. One, using the graphical representation, whereby you can draw, you're supposed to draw a straight line, and that straight line is supposed to have an arrow, okay? So when you draw a straight line, when you get your ruler, and then you draw a straight line, like maybe if I have this, so I told you this is a straight line, and that straight line must be having a what? An arrow. Now, this arrow indicates the direction as well, okay? Then the line indicates the magnitude. The line itself indicates the magnitude, okay? While the arrow indicates that there is a what? There is a direction on this vector. Then we say the second way that we can represent vectors is by use of the symbols. And these symbols here, we said we can write, like for example, you write a letter, maybe A with a bar. Then we also said you can also write A with that sign at the bottom, or you can say OA with an arrow. All these are the different forms you can represent, or you can write OA, okay? So literally, that is how we saw that we can represent our vector. Then we also went ahead and looked at directions. We said the direction of a vector, once it is in the direction of the arrow, it's always positive. But when you come back the opposite side, it becomes a negative. For example, you can say vector OA is equal to maybe this. But when you say AO, it now turns into what? Into a negative, because you are moving in a reverse direction. So literally, when you draw your line and you have your line like this, if this is vector A, because you're moving forward. But if you come back this other side, it will become negative A. Okay, so that is also something that we looked at. Then we also looked at the three classes of vectors. And we say the three classes that we have column vectors, we have displacement vectors, and we also have the position vectors. And we said when you talk about column vectors, this is how we denote them, okay? For example, when you have a point on or the point on a plane, for example, point P. If this is a point on a plane, in a vector form, it can be represented as x, y in a vector form. That is how you can represent it. Then we also looked at the displacement. We say the displacement, we are looking at the motion of a vector from one position to another. Okay, we are seeing how the vectors are being moved from one position to another. So for example, if we have 2 points A and B, we are looking at the displacement if we move from point A up to point B. And we said in such a case, with the displacement, we subtract, where we said if you have 2 points A and B, so the displacement AB will be x2 minus x1, then also y2 minus y1. Okay, this is what we had. So literally, that is what we need to look at, as this is now a displacement vector. Then the position vector, we said the position vector, usually you are coming from the original point O. Okay, and that is the reason as to why you will always find point OP, point OQ, point OA. Now, this indicates that this is a position vector. What does it mean? It means it is coming from the original point. If you have your graph, meaning it is starting from this original point or A. This is our original point. Okay, point or A. Then it is maybe moving. If this is point A, maybe this is x, x, y, and so on. So literally, we are looking. The position vector starts from this original point to the other point. So in so doing, we always represent them as either OP. There is that O. The O indicates we are coming from the original point. Okay. Then we also looked at a midpoint. We said the midpoint is basically the middle point of a given vector. And to find that, we got a formula where we say the middle point, for example, OM, the middle point OM is a half. Is a half vector B plus vector A. Okay, of which the ones vector A and B are always given. So you just add the two and then you divide them by 2, or you put their half there. Okay, and so what we're doing, we're just reviewing what we did last time. You don't have to worry about it. Then finally, we looked at operations on a vector. We saw how we can add, and we said if you're to add a vector, you just add the x separately. If you do have this, we just say x plus x1 plus x2. Then here we say y1 plus y2 in a vector form if you're to add. Now, addition is the same as subtraction. Okay, addition is the same as what? Subtraction. That is what we saw. Then finally, with the multiplication, we said we always multiply by what we call a scalar quantity. Okay, remember a scalar quantity does not have the direction. So definitely we just multiply. It's always a single value like 2, 3, 4, and so on. So these are always the scalars that we multiply with. So when you're multiplying with a vector, with a scalar, with this scalar quantity, you multiply this scalar by each of the values within. So if I have x1, I say k times x1 and k times y1. So that's what we did in our previous lesson. I wanted to review this so that when we connect for today's lesson, we get to easily know what we are doing. Okay, especially for those who are not there. Please, when you find, please make sure you find time and write these notes here in your notebooks. They are key, especially when you're carrying on the revision of your work. Okay. All right. Now, today I want to look at still. Yes, Benjamin. Benjamin has a hand. Yes, Benjamin.
Yes. Should you write? Yes, sir. Should we write right now?
No, not right now. Not right now. You shall get the notes in the Google Classroom, you download them, and then you write them in your notebooks, okay? Okay. So that's what we did last time, and we are moving forward. Now today, I want us to look at still connected vectors. I want us to continue looking at what we call the magnitude of a vector. The magnitude of the vector, and we see how we can easily calculate the magnitude of a given vector. This is our lesson for today. Actually, today we are going to look at two things, but more emphasis is on the vector, on the magnitude, and also we are looking at equating vectors. How do we equate vectors so that we can come up with the results? Okay. All right. Now, when we talk about if we have a vector, we're saying that if we have a vector A, by now we know how we can write the vector. So that introductory part was the key in our, so we say if we have a vector A, denote a vector A, for example, this is our vector A having X, Y, then we said, how do we denote? Denoting is like the way you can write a magnitude. We write the magnitude in this given form. So meaning if you're to say magnitude of vector A, you put these two lines. These two lines indicate magnitude of the vector. Okay? So wherever you put those two lines, it means you are getting the what? The magnitude. Okay? Now, to get the magnitude, then how do we, by formula, we say our magnitude of A is equal to the root of X squared plus Y squared. This is the X and this is the Y. Okay? We are saying the magnitude of A is the root X squared plus Y squared. That's how we are generating our magnitude. Benjamin, there is something? Yes, Benjamin.
Yes. My network was disturbing. I was not able to view your screen.
But
So
you're now
I'm begging
seeing
for button again.
You're now seeing the screen?
I'm seeing. I've just seen us.
Okay. So, good. Otherwise, we are saying that if you have a vector A, denoted by this, we are saying a magnitude of, okay? We're saying the magnitude of A is denoted by this. Denoting means that when you are writing a magnitude, this is how you're supposed to write it. Okay? The two lines within that. So we say that is what? The magnitude of A. Now, the formula will be, for you to calculate the magnitude of the vector, you'll have to get the root of X squared, okay, plus Y squared. Our X is here and our Y is there. We just square and then we put them in the square, in the root part of it. Okay, let's do, that's all we need to know by magnitude. That's all we need to know. Okay, this is all we need to know. The formula of calculating the magnitude. Then the rest will be quite easy. Okay. Now, please, those of you who keep joining late, don't worry. You'll get the videos on what? On Google Classroom. So you really don't have to worry much. When we come to the Google Classroom, you will see the videos and then you get that. But we are looking at magnitude. Magnitude of what? Of a vector. Okay? Magnitude of a vector is what we are looking at, dear learners. magnitude of a vector. And we are saying a magnitude of a vector is denoted by this. And by formula, we set our formula in this given what? Form. Let's do an example. Possibly we could create it more clearly. Now, before that, now, how do you generate this? Generating this is the same as the length. You know, we talked about the magnitude. It's like you're talking about the length of the line. Okay, like what is the length of that line from point O, maybe up to A? So when we talk about this is what we are talking about, graphically representing. If you have your point here, point O, if you have your point O here, okay, of course, this point O, the coordinates are 0, 0. This is your point. So by finding the magnitude, you are finding the length of this line from here up to this point here. That is what we are finding out. The length of that line is what we are denoting as the magnitude of A. Okay, or the magnitude of OA. So literally, you're finding out the line, that this distance here from this point here to this other point. If we are given these two coordinates here, that's what we are basically looking at. Okay. So so how do we get it? We always get it by Pythagoras theorem, but literally we may not go into details of getting this to the other, but literally the final bit that we need to know is for us to calculate the magnitude is literally the square root of x squared plus the y squared. This is what we need to know. But it is generated from the what? From Pythagoras theorem. That's why it is generated from. Okay. All right. Okay. So we move on. Maybe we can do what example? Let's have an example. Those of us who are working with us together, please, you could take note of it, and then we can work together. Okay. So the question is, and please, after this, get as many questions. Get as many questions to work out as possible. Let's not stop here, but after this, get more questions and then you work out, okay? Practice will make it perfect at the end of it all. So we are saying, what is the definition? Grace Anna is asking, what's the definition for the magnitude of a vector? Magnitude of the vector is the length. The length of the what? Of the line. Okay? Length of a line, of a vector. That is what we are looking at. By definition, if you need to look at, is this guy the length of the line? That gives us as tells us the magnitude, gives us the magnitude of what? Of the vector. Good. So we have a problem here that we ought to solve. Okay, we have a problem here to solve. So we are saying, given vector OP is this, and QP, PQ is this, where O is the original what? Original point. O is the origin. We are told to determine 1, the position vector, Q, and 2, we are supposed to find the magnitude of that position, that vector, that vector that we have got. Okay. Now, in our solution, when we get started in our solution, we are supposed to find this Q here, but we have OP, okay, and we also have what? PQ. Okay, this is what we have. Now, from vectors, how do we come to PQ? We need to know that PQ, okay, vector PQ is equal to OQ, okay, minus OP. I want us to have this first, okay? So when you have OPQ and you're supposed to find Q and then P separately, it is basically this Q here, okay, minus this other P. If you have AB, okay, if you have vector AB and they want you to find one of these, this is the same as OB minus OA. Okay, so let's take note of this. This is something key as far as our coverage is concerned. So if you have maybe MN, vector MN, and you're supposed to separate this ON minus OM. Don't forget to indicate that they are vectors. That's the very first step that we need to do. But remember, we have been given, remember we've been given, PQ is given, and then OP is given. But we need what? We need OQ. So what do? We now take this one, we now try to now see how we can get OP. So from our definition here, we know that how do we bring this one this side, then we remain with OP. So OP, how do we say PQ, vector PQ minus OQ, okay, is equal to minus OP. What have we done? This is what we have done. We have subtracted this one on both sides. PQ minus OQ, okay, is equal to OQ minus OQ minus OP, whereby these ones will subtract and you remain with this. Okay? So then I don't know if we are together. In case someone is lost somewhere, please you raise up from this point here. Mose, Rebecca, Mose. Let me start with Mose.
Excuse, sir. I thought that you say that PQ it's plus OP, then we will be getting OQ.
Sorry. Yes, we are finding OQ.
Yeah.
Okay. Yes. Good. I think that is a good observation. We are finding. Sorry, here I was finding OP, not OQ. Let's check this. We are actually finding what? We are finding OQ. Me, I was finding OP. Sorry. So for us to find OQ, we are finding OQ. Remember, okay, this is what we need. So meaning we are remaining with this one, this side. So meaning when this one goes the other side, we add. So meaning it is PQ plus OP is equal to OQ, okay, minus OP plus OP. And then these ones will cross out. So we shall remain with this, okay? So therefore, we shall say, from this point, we shall say OQ now, okay? OQ will be equal to PQ plus what? Plus OP. This is what we have. Okay? This is what we do have. Okay? This is what we have. What are we all finding? Our aim is to find Q. This is what we are aiming at. We are aiming at finding Q. Okay? That's our aim. Because you cannot find a magnitude of this without getting this. Okay? Now, remember our point of addition. We have our OP there and then PQ there. So what we shall have is OQ is equal to vector PQ is 5 negative 1 plus 3, 7. Okay, this is what we have, plus 3, 7. Okay, vector OQ plus what? Plus 3, 7. So when we come this side and then we are continuing here. Let me draw a line here. So we are continuing. So when you we said our rule for addition is add the x, add the y. So meaning OQ will be equal to 5 plus 3, then minus 1 plus what? Plus 7. And therefore our OQ, vector OQ will be equal to this plus 5 plus 3, we shall get 8, minus 1 plus 7, we shall get 6. This will be our Q. This will now be our what? Our Q. Of course, if you to write it in that way, this is what we do have. Let me answer some questions before I continue. Let me answer some questions before I continue. Okay, any question from this point? Please, you put up your hand. Any question to this point? Yes, Maria Tracy.
Teacher, that answer you've got the answer for OQ. It's the position vector of Q.
Yes.
Oh, okay.
That's our position. We are finding this is the position vector for Q. Okay. And we say position vector, we add what? We add the O. Meaning position starts from the what? From the original point. That's what it means. Yes.
Okay, man.
Okay. Any other? Any other query? Okay. Hey, people are losing their network. I don't know where is Rachel. Rachel, can you speak to us? Rachel?
Yes.
Yes.
I have not understood the position vector of Q.
But did you understand how we came to this formula here?
No?
Are you seeing the way that we said when you have PQ, it is Q minus P? Huh?
Yes.
And that is where we then from here we make Q the subject of the formula. And when you make Q the subject of the formula, you come to this. I don't know if you see this. Making Q the subject of the formula. Rachel?
Yes.
Is it okay making the subject of the formula?
No.
Okay, Rachel is not with us. She's not sure what. Okay. Yes, Rose. Rose?
She wanted to ask, where do you find where you have added, in which
Where?
where you have added? Can sometimes you subtract?
Now, the addition, yes. Now, how is you're asking how is the addition coming in?
Yeah.
Okay. Now, do you remember making a subject of the formula? Huh?
Yes.
Where
yes.
you have, this, the original one is PQ. This is our origin, is equal to, we said it is Q minus the P, okay? Where you have
yes.
OQ minus OP. Understood this, huh?
Yeah.
Now, we want to remain with only OQ, which we want to decide. If you want to remain with only OQ, it means we are eliminating this one by adding it. Okay? We are eliminating this one, this side by what? By adding. So that's why you're saying we have PQ plus OP is equal to OQ minus OP plus OP. When you get a number minus 1 plus 1 is 0.
Yes.
This we compare it to this one here. So that's why these ones cross out. Okay?
Okay.
And you will remain with only OQ. So therefore our OQ will be PQ plus OP. Is it clear now?
Yes.
Okay. So sometimes we can subtract. It's not a must that it has to be addition. Sometimes you can subtract. Okay. Any other question? I want to exhaust this so that we get to understand it clearly. Daphne? Yes, Daphne? Miss, yes, Daphne.
So now, why have you said that PQ is the original one?
No. It's not the original one. It is what we've been given in the question.
Okay, sir.
The question has given us PQ, but from PQ you can find what? OQ. Okay.
Okay, sir.
Yes, we've got it from the question. Any other? Okay. I think that is clear now. I think that's now clear. So, dear members, when we are finding this is how we are coming to our position vector Q. Okay. Now, the second part is asking us to get the magnitude. Let's write it here. The second part is to find the magnitude of OQ. Okay, but we know that the position vector OQ is equal to, was it 8, 6? This is our position vector. So from this one here, we can find our magnitude. So our magnitude, we know that the magnitude of a position of a vector is the same as the root of x squared plus y squared. Please always first write your formula that you're going to use before you start writing the result, or you start answering out. Don't just from nowhere you start writing your square root and what. First put for us the formula that you're going to use. Okay, so from here we now say the root of, here we know x is equal to 8 and then y is equal to 6. Okay, so therefore we shall get 8 squared plus 6 squared, and this will be equal to 8 squared is 64 plus 6 squared plus 6 squared, which is 32. Okay, someone has already got the answer. Has someone already got the answer for us? This is 36. Okay. Then when you add the 2, 64 plus 36, you get 100. So we get the root of 100. So what is the root of 100? Okay. People already got, it is 10. It is 10. So therefore, the magnitude of OQ is equal to 10. You can call it 10 units. Sometimes you can put it in that given form, 10 units. Okay? That is our magnitude. That's the magnitude that we are required to find. So therefore, I wanted to bring the point of easily calculating our magnitude. So sometimes you can be told to first find a position vector or to first find the displacement, as we saw last time. Then from the displacement, somewhere you can start adding values, then from there you get your magnitude of the vector. So dear members, this is how we can generate our magnitude. Now, questions are going to keep on enlarging as we continue, because they are going to keep on enlarging as we continue, okay? Now, as they, like you can be taught first find the position vector, then you can be taught find the displacement, then you can be taught to then finally get the what? The magnitude. Or at some point you may be taught to get the midpoint and so on. So let's keep all these concepts together so that we work them out. Okay. Now, that's how we get it. Now, another thing that I want us to keep adding on is what we call equality of vectors. Okay? Equality. How are vectors equal? When are vectors equal? Okay. Dalton is asking, how do we find the displacement? Please check in our previous notes. Our previous notes, we saw how we can calculate the displacement. Rodrigo, Google Classroom, check the messages. We posted that in the class in the message chat. So check through. Okay. Check in the message chats. You'll get those links from there. Those of you who are just joining. So when do we get a vector to be equal? When do vectors be equal to each other? Okay. And we are saying, if vector A is given by this, by column vector, this, and vector B is given this, then we say, okay, look at this. When we have the same values, this to the other one, then we say vector A is equal to vector what? Vector B. What does it mean when you say that a vector A is equal to a vector B? What does it mean? Now, it implies that, okay, that the value of X is equal to the other value of X, meaning you can equate them, okay? And also, it means that the value of Y, so this is maybe value of X1, this is also Y1, this is X2, this is Y2, meaning the value of Y1 here is the same as, or it is equated to what? To the value of Y2. Now, why do we bring up this? This helps us to find unknowns. It helps us to find unknowns. The unknowns can be either an unknown vector or unknown what? Scalar. Okay? It can be an unknown vector or an unknown scalar. So when we say that they are equal, it means you equate these ones here. You equate the X's and you also equate the what? The Y's. Okay? You also equate this one to this one here. So therefore, we can now say that these vectors are equal. I hope we are together on that. Okay? So literally, if you're to find something, you equate this to this, this to the other. Then from there, you can now calculate whatever is required. Okay? Let's show this by example. Let's show this by example. Okay? They say, given that vector A is given by that, vector A is given by 2 plus 3x for x, then this is 4, and B is given by 6 minus 4x, then 8 minus 2y. Solve for x and y. If vector A is equal to vector B. Okay? If vector A is equal to vector B. So we said that if we say that vector A, if in our solution, if vector A is equal to vector B, then we know vector A is 2 plus 3x, then 4 is equal to 6 minus 4x, 8 minus 2y. This is what it means, dear members. Okay? And we say from our concept of equality, when we have from our option from our equating, we know that A1 is equal to B1 and also A2 is equal to B2 from the part of equating vectors. Okay, so this means that this one is equal to this. Okay, and also this one, this 4 is equal to the 8 minus 2y. That's what it means. So we go ahead and we move ahead and answer, having known that. So therefore, we shall have 2 plus 3x being equal to 6 minus 4x. This is our first equation. There is a hand somewhere. I always told you to label your devices. And if you don't label your devices very well, I always find it difficult to pick you up. Now there is someone called Raf. I don't know if Raf, that's your name. Please label your devices. Label your devices. It makes life easy for me. Okay. Anyway, so we are saying this is what we are saying with the equivalent. So we equate this to this one here. The upper one equates them, while the lower one also equates them. Now we know how to solve equations from our algebra of senior 2, collecting like terms. Okay. Here, what do? We collect like terms. Our aim is to find what? Is to find x, since it is what we have in our equation. Okay. So therefore, what we are going to do, we are going to collect our like terms. So we can say the 6 comes this side and the 3 goes the other side. Okay. So let's bring the 6 this side and then the 3 goes the other side. So we shall have 2 minus 6 is equal to, okay, let me try to simplify it. Some people may not get it easily. Okay, so we said 2 minus 6 plus 3x minus 3x equal to 6 minus 6 minus 4x minus 3x. Okay. Now this one will disappear. This one also will do the same thing. Okay. So 2 minus 4 will get, sorry, 2 minus 6 will be negative what? 4, which is equal to minus 4 minus 3, we get minus 7. Minus 4 minus 3, we get minus 7 what? X. So you divide through by 7. Our aim is to find what? X divided by 7, negative 7. So therefore our X will be equal to 4 out of the 7. Hey. Now this is our algebra. We're back in senior 2. Collecting like terms, Okay. When do we subtract? When do we add? Anyone stuck at that point before I continue? Anyone who is stuck? Okay. Yes, Kauma.
Teacher, I'm stuck from the beginning.
You can't be stuck from the beginning. Where is the beginning? From where?
No, where we collecting the like terms.
Where we do what?
Where we started collecting the like terms.
Where you started collecting like terms. Okay, now that's not the beginning. Okay, I'll repeat that. Daphne, where are you stuck from?
Sir, okay, I have a question. Sir, now here we have got the answer as 4 out of 7. But if it is reducible, can I reduce it?
Definitely, you can reduce it. Very, very fine.
Okay, sir.
All right. Yes, Moronji Davis. Moronji?
Sir, I'm stuck from collecting like terms address network.
We are stuck from collecting the like terms. Eh? Okay, now
yes.
let's collect these like terms together. I want us to, I think that's where most people are getting difficulties from, possibly. Okay, now when you're collecting like terms, now this takes us back to our elementary math. We call it the elementary one. Now, when you're collecting like terms, for example, we have 2 plus 3x is equal to 6 minus 4x. We need to bring, okay, let's look here. We need, when we are collecting collecting like terms, like for example, we first start by bringing the 6 this side, this other side with the 2. So for us to bring the 6 this side, we subtract it on both sides. Okay? So we shall say 2 minus 6 plus 3x is equal to minus 6. Sorry, 6 minus 6 minus 4x. So you'll have eliminated this. Okay? Now, so therefore you're going to remain with minus 4 plus 3x is equal to minus what? 4x. This is what you're remaining with. Then we also need to take this 3, this 3x, this other side to be together with the 4x. So what do you do? What do? We now also subtract it on both sides. So you have minus 4 plus 3x minus 3x equal to minus 4x minus 3x. So therefore, you'll have eliminated this one also. So you remain with minus 4 being equal to, when you get minus 4 minus 3, this is minus 7. Okay? That's minus 7. So therefore, you'll get minus 7x. So what do we do from here? We divide on both sides. We divide minus 7 on both sides. So we shall remain with the x. Of course, this positive, this negatives also disappear from here. And also we shall remain with 4 out of the what? Out of the 7. Is that easier now? Is that easier now? Yes, Patience. Patience?
Sir, yes. I was wondering how comes we didn't include 8 minus 2y in collecting like terms?
No. We are saying that in our equivalent, we are solving this one first. Okay? We are solving the top one first. Are we together? Then after that, we come to the bottom also. This is our second equation. Okay? You solve the equation separately. That's what we do have. Okay? I hope, Patience, that is clear now. Justin Ainembabazi. Ainembabazi. Yes, Justin. Justin, yes? Okay. Yes, Ralph. Ralph? Okay, seems to be there now.
Teacher, I got 7x out of 4.
Pardon?
I got 7x out of 4.
From where?
Like
X is equal to 4 out of 7.
Yes.
Like you got the same answer with us?
Yeah. Like
Okay.
I got 2 minus 6 and is equal to negative 4, 4x minus 3x.
Yes.
Then 2 minus 6, that is negative 4, is equal to negative 7x. Where you get, then out of negative 4, then negative 7x out of negative 4. The answer is...
Mbabazi, stop, just pause there. Just a point of correction. When you reach here, you see this last step? This one of dividing here. Our aim is to remain within the x this side, because this is what we are finding.
Okay.
So that's why we divide by negative 7, divide by negative 7. Got it?
Yes.
That's why our x is 4 out of the what? The 7. The negatives also disappear. Okay?
Okay.
They cross out to get that. Good. Thank you. All right. I think we've got that. We've understood that now better. Now, okay, so this is our x. We've got our x. Now, the next stage that we have is calculating our y. Now, we need to find out we need to find y now. Now, for the y still, we are doing the same thing. We are equating this one to this. The 4 is equal to 8 minus, some of you should have got it already. So we are equating 4 is equal to 8 minus, is it 2y? Yes, minus 2y, okay? So we also do the same thing of collecting like terms, okay? So collecting like terms, we bring the 8 this other side. Then the 2 remains the other side. So we shall get 4 minus 8 is equal to 8 minus 2y. So these ones disappear. We cross out because 8 minus 8 is 0. Okay? So 4 minus 8, we shall get our negative what? Negative 4, which is equal to negative 2y. Then you divide it through by negative 2, divide by negative 2. When you cross out this, our y will be equal to the negatives turn into positive. David was asking at some point that if it is supposed to be reduced, do I reduce? Yes. So this one, you reduce it by 1, then this one will be 2. So therefore, your y is equal to what? Is equal to 2. Okay, so therefore, x is equal to 4 out of 7, and y is equal to what? Is equal to 2. Okay, y is equal to 2. I don't know if we get that. Okay, let me answer some questions. Y is equal to 2. Okay, I think someone has also got the same answer there. And let me answer some questions as we end up closing. Sports outreach, I don't know your name. Please enable your device. Brighton, is it Brighton? Brighton. Brighton, you're asking? Yes, Brighton. Hey, Brighton is off, huh? Okay. Yes, Kylie. 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 Hey, people are off. Huh? Yes, Martha. Martha.
Excuse me, sir.
Yes, please.
What I was wondering, what if there is another equation going on and this is 4 out of 7? How can you do it? Like x is 4 out of 7 and there is another equation going down, like continuing. Like what if the fact that x is 4 out of 7 and y is 2 equals 2?
Yes.
What if there is another equation continuing from when you have to construct like a graph? How does it go?
I don't know if I've understood your question well.
Okay.
Yes, I'm failing to. Are you saying that if you are having, maybe if this is the x, this is the y, and there is another z somewhere?
Yeah.
You still equate. Huh?
Okay.
Yes, x goes to x, y to y, z to z. I think that's what you mean.
Yeah.
Okay, thank you. Any other query? I think that's it. We've now got that concept. Can you reduce? Yes, you can reduce. Okay. Yes, we can reduce it. Okay. So please make sure that once you get there, you can still reduce your equation to the lowest point possible. Okay. You can reduce your point to the lowest term possible. Okay. All right. Let's continue. I think that's it. That's how we could get that. Now, there's another one here, which I'm sure you can now work out for me this. Okay? You can also work out for me this. Yes? So we are saying, we are being told to find the value of x and y if we have this is equal to the other one. Okay? We said we are using we are equating. Okay? What are we doing? We are equating. So we say negative, if we have this, we are going to equate, and after equating, we collect like terms and we find. Let me work out A, and I'm going to leave you with the B to work out. Are there graphs? Usually we don't work so much with graphs in vectors. In this particular topic, we don't work so much with vectors. We always work with just these calculations. That's what we always work with. So let me work out this one here, and then we shall see the next one. So we say we have let's work out this. We have -9, -3, -3 into xy is equal to let's use this, is equal to -2 is equal to -2. Okay, is equal to -2 into, I think this is 32. Okay, so what do we do? Our solution is simple. Please, we are applying the concept of equivalent fractions. Sorry, equivalent, we are equating our vectors. So in our solution, what are we doing? We first need to multiply this scalar. I think we learned how to multiply the scalars. So where we shall have -9, -3 into minus this 3 times the x, we get 3x. Then the 3 times the y, we get our 3y. Okay, so we get this as a single vector. Then you also do the multiplication of this scalar. -2 times -3, we get -6. Then here we also get negative what? -4. Okay, so from here we do the equating. Okay, Now, this is now more easier. Please, when you're equating, you even go up to the end, the extreme end. So here it's like A is equal to B is equal to C. That's what we do have. So therefore, we shall have negative 9 minus 3x is equal to negative 6. Okay? Then we shall also have, this is our equation 1. We solve this equation 1. So in solving this, we shall get negative 9. Okay? We want to take it, because we are collecting like terms. Please learn how to collect like terms. Then plus 9 minus 3x is equal to negative 6 plus 9. Why are we adding? We are eliminating this 9 here. And to eliminate the 9, we add it to 9. Okay? So we shall have negative 3x is equal to 3. So it's equal to? Is equal to 3, I think. Is equal to 3. Okay? We shall have it equal to 3. Okay? So therefore, we divide through by negative 3, divide by negative 3. Please, we are dividing by negative 3. So therefore, our x will be equal to negative 1. Okay? Good. Some people have even already got the one for y, yeah? Which is very good. So then for y, we do the same thing. Minus 3 minus 3y is equal to minus 4. Okay? Collect like terms. Bring this one this side, and then bring 4 this way, and then 3 take it the other side. Or you take just the 3 the other side. So we shall get minus 3 plus 3 minus 3y is equal to minus 4. Okay? Plus what? Plus 3. So this one will disappear. So we shall have minus 3y is equal to minus 4 plus 1, we get minus 1. Sorry, minus 4 plus 3, we get minus 1. So you divide it through by negative 3 by negative 3, and our y will be 1 out of the 3. Quite easy and quite simple. Okay? So literally, that's how we are going to work out with the vectors. And you're going to work out for me this second one. And this second one here, we are saying given we have P as this Q is that, find T if T is a, remember our T is what? Our T is a scalar, okay? Our T is a scalar. This is what we are going to solve. So meaning you bring your, we are saying we have T, the magnitude of P is equal to Q magnitude of that. So just do the substitution and then you come up with your final answer. Can I take some questions before we come to a close? Our time is fast spent. Let me take some questions. Seems it's gone well for most of you. Let me take some questions. Okay, any questions? Okay, yes, Brynette. Yes, Brynette. Okay, Brynette is off. Alvin Chisache. Yes, Alvin Chisache.
So if I'm to ask,
yes,
what is going to be the effect of the scalar in this equation?
What's the effect of the scalar? The scalar will multiply this P. Huh? The scalar is going to multiply this P here. That is the effect. Then afterwards you equate. So when you equate, you realize that you're going to maybe, if you may have 3t equal to maybe 5. So this t here, at the end of it all, you're going to get the t as the scalar. That's its effect. Okay, then finally, Daphne. Finally.
Okay, sir. Now, sir, for me, I've realized my problem because I had a problem of collecting the like terms whereby I could get a wrong answer, but now I'm okay.
All right. Thank you. Good. Glad you're there. I think the rest are also there. And you help with the WhatsApp link and everything. Please, for the WhatsApp link and then the Google Classroom, please check in our chat. We've shared with you the link. So you can try to join through. I think that's it. All right, dear members, so you will go and work out that. You will go to that and then you work out that this number. This is the only number I want you to. This is my assignment for today. Okay, okay, I think we can close, yeah, unless Bakita.
Yes, teacher, sorry for asking question at the last moment, but
Yeah, please
about the assignment,
do
you first find the magnitude of P and Q, then you find the value of T.
Finding the magnitude
of T, of P and Q, then you find the value of T, or you first multiply the scalar of T by P.
Do you see that we have when you have the magnitude, if we say magnitude P, it means you're supposed to get this magnitude and then multiply it by the what? By the T.
Okay, thank you, teacher.
You're making me work out the assignment for you already. Okay. All right, dear members, I think we can close here unless Mr. Dumba has something to put across.
There is nothing to put across. I've sent all the links in the chat. And I think those will work for them. I even sent them a video of how to join Google Classroom yesterday. I hope they are fine.
Okay. All right, dear members, thank you so much for attending. Let's please work out this by what? Let me give you by the end of by 4. When you're done with that work, then in our next lesson we shall also look at something else. I wish you a good day and a nice week.
Mr. Musamali.
Yes, please.
Just one more thing. Can someone from the group tell us who is sponsoring these e-classes? Hello, students. Let me see. Dalton, who is sponsoring these e-classes?
S.3.
Yes, S.3 Uganda. Thank you so much, Dalton, for knowing that. We can now close our classes and meet with the next.